Assalamu alaikum warahmatullah. Welcome to another beautiful class of the continuation of the chapter Acid, Base and Balance. And this class is about a base and alkali. So you know already about the definition of acid, the properties of acid and some neutralization reaction. So I hope you have some idea about what is alkali and what is base. So there are some differences between that, and we need to think a little bit more about base and alkali in this lesson. So what is the definition? If you see that generally metals or metal-like reactive radicals. So here we know that this is about metal plus metal-like reactive radicals, oxides and hydroxide. So we know that this should be like metal, or you can say that metal or radical and with oxide and hydroxide. We know that the reactive metals, we know that the reactivity series of metal like sodium, potassium, magnesium, calcium, aluminium, zinc, these are the reactive metals. And with these oxides and hydroxide, if it combines the compounds and that undergo reactions with acid and produce salt and water. We know another basic that when acid undergo reaction with base or alkali, then it produces salt and water. So this is very simple. We know this is a neutralization reaction. So what is base? We know that the metals or metal-like reactive radical, oxide and hydroxide. Now let's think that what are the reactive metal and oxide. If you think about calcium, if you think about magnesium, if you think about sodium, aluminium, zinc, iron, okay, let's think about it. And if it is about radicals, then it should be some positive radicals, because these oxides and hydroxide are the negative ions. So we need a positive radicals to form a base or alkali. And what are the positive radicals? You know that phosphonium and ammonium. So we can think about it that pH4 plus and NH4 plus, these are the radicals, which is reactive radicals. Now think about what can be the compounds combined these metal and metal-like reactive radicals with oxides and hydroxide. We know that if it is oxide, the valency is 2 and this is 1. So when it will add with calcium oxide, it will produce like calcium oxide, and in case of calcium hydroxide, it would be like CaOH whole 2. This is very important to know the compounds, and this is a basic. Those who have a problem that why this is OH2 and 3 is about that, I am suggesting you to please see my tutorials about chemical compounds. On that tutorial I explained that what is the criteria and what is the process of writing down the compounds. So in magnesium it would be like magnesium oxide and it would be magnesium hydroxide, because the valency of magnesium is 2. In case of sodium, it would be sodium oxide and sodium hydroxide, because the valency of sodium is 1. About aluminium, it would be aluminium Al2O3, this is aluminium oxide, and this is AlOH whole 3. This is aluminium hydroxide. You know the compounds of aluminium hydroxide, these are all base. So zinc, in this case it will be zinc oxide and it will be zinc hydroxide. Here ferrous, we can say that this is ferrous oxide, or we can say this is ferric oxide, or even we can say this is ferrous hydroxide, like that. This is phosphonium oxide or phosphonium hydroxide, so PH4OH, and very commonly we know this is ammonium hydroxide. So these are all examples of base. So you can write a lot of examples, like you can think about any reactive metal and then combined of oxides and hydroxide will produce base. Now, in my previous video where I explained about neutralizing reactions, then you can take any of them. These are all examples of base, and if you add any acid, take everything here in base and take any acid, hydrochloric, nitric acid, whatever. You can think about hydrochloric acid, nitric acid, you can think about carbonic acid, we can think about phosphoric acid, we can think about sulfuric acid, whatever acid you can think about it. So if you make a reactions among these examples with that, hopefully you will find every time the neutralizing reactions, and that is actually will produce salt and water. And I'm not going to explain it because I have already explained it in my previous video. In this video I'm just focusing on this. So these are the example of base. Now what is alkali? Alkalis are not but those base that actually dissolves in water. I mean, among these, think about simply that sodium hydroxide, calcium hydroxide. Just these two examples. These calcium hydroxide and these sodium hydroxide. Think about it. These two are base, and also these are actually soluble in water. So that is why we can say that these are alkali. So the alkalis are soluble. I mean, we can say that those base are soluble in water. So simply, all alkalis are base, but not all base are alkaline, because not all base are soluble to water. So that is why there are maximum base actually, those who actually don't dissolves in water, but there are some examples. This is called alkaline. So this is alkali. So we can say that alkali is those base that actually dissolves in water. Among them, you think about, there are very common compounds that in our day-to-day life we use. This is ammonium hydroxide that you find it in a glass cleaner. In the glass cleaner, this is a basic. So glass cleaner, if you see in glass cleaner, this ammonium hydroxide is present. In this sodium hydroxide, this is also present in toilet cleaner. And now, what are the properties of base? If you see that, number one, the properties of base is, you can say that litmus paper or litmus test. In case of litmus test, the red litmus paper will turn into blue when it will add with blue when it's some sort of like basic solutions will be added. So litmus test shows that this is basic solution, because when sodium hydroxide solutions or even any basic solutions, if you add with litmus paper, the red litmus will turn into blue. Another, in case of fillings, if you touch sodium hydroxide, then in case of filling, all basic compounds are slippery. All basic compounds are slippery. This is important. When you touch, you'll feel like it's slippery. And then there are some reactions that will actually express the properties of base. Think about some sort of like salts. Like, think about it. I'm just giving us an example. Think about some sodium hydroxide. Okay, this sodium hydroxide solutions is added with first thing, I think, like calcium nitrate. You think about it, calcium nitrate or aluminium nitrate. Then think about ferrous nitrate, then ferric nitrate, and then you can think about copper nitrate, copper nitrate, or even you can think about for calcium, aluminium, iron, 2 in copper and zinc nitrate. Okay, so there are some examples. You can think about calcium chloride, aluminium chloride, ferrous chloride, ferric chloride, whatever. These are some salts that if you add with sodium hydroxide dilute solution, so there are some examples that we can think, or we can actually identify about the colors of the precipitations. Think about it. So what would be the examples? First, this is calcium positive. If is add with hydroxide, then it will produce that calcium hydroxide, and this is 2, so it must be here will produce 2, and then sodium nitrate will produce. This will be sodium nitrate. So 2 molecules of sodium nitrate will produce. Think about it. Again, if it is sodium hydroxide, so aluminium hydroxide will produce. So it will produce aluminium hydroxide. Now, what is the basic formula of it? So if it is OH whole 3, so it must be 3 here, and it will be like 3 molecules of sodium nitrate will be added. So how would you think about it? Calcium hydroxide, if it is a precipitations, aluminium hydroxide is a precipitations. In this case, ferrous nitrate, ferrous hydroxide will be precipitate. Ferrous hydroxide here, ferric hydroxide will be precipitate. Here, cupric hydroxide will be precipitate. Here, zinc hydroxide will be precipitate. Now you think about the color of it. In this color, everything is at like this is white precipitation. Aluminium is white precipitation. Ferrous, this is green precipitation, and ferric hydroxide, this is reddish precipitation. In this case, this is light blue precipitation. Zinc, this is white precipitation. Now you think that when any base undergoes reactions with this sort of salt, metallic salt, it can be same for think about calcium chloride, calcium sulfate, calcium sulfide, whatever you think, whatever, but this is metallic salts. When it undergo reactions with base, then the individual ions has its own color of precipitation. So calcium color, so calcium 2+ will have white precipitations, aluminium 3+ will have white precipitations, ferrous will have green precipitations, ferric will have reddish brown precipitations, copper 2+ will have light blue precipitations, and zinc will have white precipitations. So this is very important to understand or to identify the color of the precipitations. Even think about if it is ammonium or ammonium chloride, and then if it goes any sort of basic reactions, like if you think ammonium, okay, so ammonium chloride, okay, so think about ammonium chloride. It undergoes reactions with sodium hydroxide. Think about ammonium chloride goes with calcium hydroxide. Even ammonium chloride undergo reactions with calcium oxide. If it is ammonium chloride or ammonium salt, then it will definitely produce ammonia gas. So see, the reactions would be if it is sodium, right? That would be sodium chloride. So sodium chloride plus ammonia plus water. Same. So the ammonium and calcium hydroxide, they will produce calcium chloride. So it will produce 2 molecules of ammonia and 2 molecules of water. Similarly, this one would produce calcium chloride. So it will be 2 molecules of ammonia and 1 molecule of water. So this is very simple reaction that actually some of you that may have questions that is this reactions is important. For example, I say that you should try maximum in case of practicing these reactions, because it will definitely enhance your idea about chemistry, and chemistry is about reactions. When you will study this chapter, try to think that this is something very easy. So whenever you will understand about base and alkali, try to understand the definition of it, and these are the examples, and there are some sort of properties that I have explained here. So I hope you know about base and alkali, and in the next video I shall come up with acid rain and some sort of like water pollutions and hardness of water, like BOD, COD, and the purification process of water. So see you on the next video. Keep watching these tutorials and let me know your feedback. I shall be so much grateful to you if I have your feedback. Thank you so very much. Stay well. Bye.